It's hard to convey something like the Higgs boson because it's a difficult concept, but I think if you do it right, people like a good story. People love a good narrative.
You know, perhaps once in a lifetime, something will happen that changes the course of history forever.
It may come as a surprise to the technological believer accustomed to the mystical aura that surrounds these Big Bang machines to learn that these quark explosions will not unravel anything new or relevant to our knowledge of the universe. Why? Because the excuse used for decades to push these colossal industrial projects, the Higgs boson, which was marketed in the press as the God particle, has already been discovered. And with its detection, the standard model of quantum particles is now complete, and there are no longer any new fundamental particles to unravel in these collisions. The Higgs is just another boson within the extensive zoo of nuclear species. Certainly not the meaning of mass, which is perfectly explained by Einstein's energy-mass equivalence. And so, despite decades of hype narrative, the sad truth is that studying the Higgs boson is irrelevant for science, because the true purpose of its sanctification was to create the perfect excuse for the industry's lobbies to extract billions from clueless politicians so that the atom smasher industry could continue making bigger and faster Big Bang machines.
We are faced with another incredible leap forward, one which stretches the limits of our imagination, yet one which will surely have a great effect upon each and every one of us on this planet in the not-so-distant future. I am speaking, of course, about the superconducting super collider, a 52-mile oval-shaped tunnel.
I pushed very hard for something called the superconducting super collider in some curious place. I think it was Texas, is that the right place? Waxahachie, as the governor said. In order to, and that where the drive was many things, but in order to focus the drive, we talked about the Higgs particle.
The hope is that the appearance of new particles with exotic names like Higgs bosons, squarks, and sleptons will open new vistas of inner space.
But I was a propagandist for it. I just said that the Higgs is a very powerful argument for building this machine. And there are other arguments. There was a new energy frontier.
Jobs, and as many as 500 visiting scientists.
But we pushed hard, and we gave millions of talks around the country, and then we had to convince the Department of Energy it was a good thing to do. Then we had to convince the President of the United States. So that was President Reagan at the time. And we had to make a video that was less than 10 minutes that we could show the President that he would understand why we wanted a superconducting super collider to find the Higgs particle. Good luck.
In order to sell the super collider to a born-again Christian president in the 1980s, Leon Lederman, a lobbyist for the industry, changed the Higgs boson's name to the God particle, while Nobel laureates Steven Weinberg and Sheldon Glashow baptized the Higgs as the toilet particle because of its insignificance, as any student of physics learns at a university.
Stanford University.
The goal tonight is not to tell you why the Higgs boson is the best thing since flush toilets. You've read all of that. Anybody who's here has probably read all of the hype, the excited, breathless superlatives that have hit the newspapers and so forth. The Higgs boson is going to explain the origin of the universe and this and that. I'm not going to do that. Well, there are lots of things in nature that have mass and have nothing whatever to do with the Higgs phenomenon. Let me give you an example. Are there any particles which are like this, which get mass having nothing to do with Higgs or anything else? Yes. The proton. The proton is a particle which is made out of quarks. Quarks, 3 quarks, and a bunch of gluons,
which are the components of all the atoms and most particles in the universe, and whose mass is certainly not explained by the Higgs, but rather by Einstein's beautiful principle of equivalence between energy and mass.
He sought what he called a simple and lucid image of the world, a single principle that would account for the baffling differences between the forces and the great variety of particles.
Einstein's principle describes the equivalence between the gravitational energy of vacuum space and cyclical accelerating vortices of mass, two types of motion which differ only in their form, but with the capacity to change into each other's shapes eternally.
Einstein put the idea this way: what if someone were in a rocket ship far from Earth? He would still float with no gravitational field to hold his feet to the floor. But what would happen if the rocket began to move? As it accelerates, the floor of the rocket rises. On its way up, it would catch the passenger, and to him, it would seem that gravity was holding his feet to the floor. And if gravity and acceleration feel the same, perhaps they are the same.
The universe that Einstein helped unveil had no substance, but rather two complementary forms of motion. This was also foreseen by Descartes and Newton, who described all forces of nature as made of expansive spatial motions and cyclical accelerating vortices of mass, which combine to create the infinite waves of energy and clock-like particles found in a universe in perpetual transformation.
Every mass is associated uniquely with a corresponding frequency. This is actually the pion. There would be similar pictures if you looked at protons and neutrons. So this is our deepest understanding of what protons and neutrons are. They are the tones, the frequencies of these vibration patterns in the dynamical void.
The only difference between a space-time vortex of mass, a water eddy, or an air hurricane is the medium they absorb and are made of. Like a hurricane, where rotational speed determines the attraction it generates within its medium, a mass, which is an eddy of informative time, attracts more invisible energy in space the faster the frequency of its rotation. This is why black holes, which spin at the maximal light speed of the universe, are the most attractive entities in the cosmos, followed by quark stars, with a frequency of rotation of milliseconds, and in the smallest quantum scale, quarks, which rotate faster than any other particle and store most of the mass of an atom. The other form of motion, which is the pure linear energy of gravitation and light, with a lineal speed that is the maximal in the universe, is an expansive force, meaning it will never close its waves to attractive cyclical vortices or have any mass. However, because one motion can change its shape into the other, colliders transform linear electromagnetic energy into a cyclical mass, creating strangelets in the process. This is simply the inversion of the technological process that allows nuclear bombs to dissolve cyclical mass into expansive lineal energy.
Einstein's famous equation, E equals mc squared, told us that energy and mass were interchangeable. It gave us the knowledge to build weapons of mass destruction and the knowledge to understand how our universe was born. When a nuclear bomb explodes, a tiny amount of matter is completely annihilated and converted into energy. But in the Big Bang, the exact opposite happened. Pure energy was converted into matter.
How is it possible to construct heavy objects out of objects that don't weigh anything? And the answer to that challenge comes from Einstein's second law, m equals E divided by c squared. If you think about E equals mc squared, famously, what it suggests is the possibility of getting large amounts of energy from small amounts of mass. And so it suggests things like the possibility of making nuclear weapons. But if you write it this way, it suggests the possibility of explaining mass purely in terms of energy. In fact, really, this should be called Einstein's first law, or maybe his 0th law, because this is the form that he actually had in his original paper. Does the inertia of a body depend on its energy content? So right from the beginning, Einstein was thinking of the possibility of creating mass out of pure energy. And remarkably enough, that's what actually happens in our modern theory of quarks and gluons and the strong interactions.
The way they do it is simple. Colliders give energetic boosts to mass vortices to speed them up. But because nothing can go faster than a ray of light, when quarks approach light speed, further acceleration curls their lineal velocity, speeds up their rotational mass, and increases their attractive power, transforming them into heavier, strange quarks in the process. When the accelerator crashes these masses together, it liberates the quarks, which then form a liquid vortex, or strangelet, that could theoretically start a chain reaction by attracting the much lighter energy mass in its environment and crunching the planet into a strangelet. The formation of a strangelet is by no means a rare occurrence and can be observed in supernova explosions all over the cosmos.
While we see the outward explosion as a supernova, this masks the inward implosion. The core is collapsing into the most dangerous object in the universe. The density becomes so great in the center that gravity sucks in time and space itself from the outside universe. A darkness forms at the heart of the collapsing star.
In the nuclear industry's safety reports, strange liquid is a threat to minimize. So physicists and the press have ignored that strangelets are being created in most of these collisions.
Most of the interactions that we see, they immediately create a pattern that we recognize as not interesting, and we can reject them. So we reject by far the vast majority of the collisions.
When independent scientists warned the public about these dangers, the industry paid for an expensive marketing campaign that highlighted the production in 1 out of a trillion of those collisions of a rather irrelevant particle called the Higgs boson.
But this type of collision, to make a Higgs boson, almost never happens.
So far, I have not mentioned the Higgs boson. So what is the Higgs boson? You have a condensate, and you can imagine the condensate has a density of these fictitious particles in the condensate. Imagine something which changes the density of them, kind of like a sound wave, a compression wave of some kind, which squeezes them closer and further and closer apart, makes them more and more less dense. That kind of vibration is what a Higgs boson is. The Higgs boson is like the sound wave propagating through the condensate. So it was the one element that had not yet been discovered. As I said, the Ziggs was discovered long ago. The Z and the W, the electrons, and all the others were discovered long ago.
So now that this little vibration has finally been found at a cost of $13 billion, the Standard Model of particles is closed. There is nothing left to unravel with those collisions, except an ICE-9 extinction. But this cannot be said to the public. So the nuclear industry denies all the risks it creates and erases the truths of science by repeating ad nauseum its litanies about the all-powerful particle that gives mass to the people.
You guys found boso in your detector?
Well, not exactly. We found a boson, probably the Higgs boson.
What's that?
That's a particle.
Don't you find particles all the time?
Yes, but this one is all around us, everywhere in the universe. And what it does is rather special. It gives mass to elementary particles.
But those who impose truth with power will be the laugh of their gods, said Einstein. A smiling Shiva, god of energy and death, patron of the nuclear industry, with its statue presiding over the largest of those particle colliders, seems to agree.
It's amazing that the Higgs, the center of the Standard Model, the thing we've all been looking for, could actually also be the thing that destroys everything.